presentation on David Bohm, and the reason for that is David Bohm is an exponent of quantum mechanics, and we are currently in this video series attempting to discover for the first time just what is quantum mechanics. The best way to introduce that, so you know how I approach this marvelous topic, that it's a system of paradoxes. You could say it either way, and that's a very important point that I want to draw out so you'll know what's ahead. In order to even think about the quantum paradox, which nobody understands, or can even state what it is, except in the most roundabout ways, the only way to actually even have a framework of approach is to first understand that it is not going to be a typical answer. What we're facing is a limit, and that's just another way of trying to corral or somehow identify what is the problem, which is extraordinarily far-reaching. The quantum paradox system must be understood. There is no way to avoid this question. It goes to the actual solutions of what science is for at all. And so what I want to draw out for your very important attention at this moment to prepare the way is that the answer is superpositional. Generally speaking, the concept of superposition is an attempt to identify a different form of logic than science actually uses. So you can see we're hamstrung, and that partially explains why this is so difficult to name, is what is the problem? The solution will be given. I will give you the solution to that. But in order to do so, you first have to realize how difficult it is to do. And the second point in my approach is that it will have a superpositional answer, which means what? It means there will be two answers. That's the first step to understanding superposition, is that the result is nonlinear. It's a nonlinear form of logic. Is that even possible? Deduction and induction, which is kind of its inverse, are drawn into the question here because that is logic. It is a dual system of deduction from facts and induction, which is the synthesis of those facts into something meaningful. And it also has another recursive definition, that is induction, because it's how you define things, is using an inductive system, which is kind of the reverse of deduction, but it is dualistic. It's superpositional. It's a very good example of superposition. A physical example of superposition is electromagnetism, EM, which defines the electron and it defines the photon. So electromagnetism is a very important concept. It's an example of superposition because you never have electricity without magnetism. It's a well-known fact. And it can be said in the inverse, that if there is magnetism, there's electricity. But then you would have to define what you mean by electricity. And that's called electrodynamics. So we are talking about the very fundamental approach system that science uses to get at truth, which is involved here, truth, which is kind of mysterious. I mean, truth, we as mechanistically thinking men, as we're trained to be as scientists, okay, for what? You want truth? Well, it's a form of recursion, because you're trying to define what it is you're trying to get out of science. I don't think anybody's ever done that. Of course, it's been attempted, but mostly, I would say, in poetry, a poetic approach. Now, over here, we're going to approach this most interesting question of what is the problem? One man got a solution, and only one man out of the entire Einstein, Dirac, Schrödinger, Heisenberg, Bohr, Feynman, and then, of course, there are then hundreds of names and then thousands of names. And then it involves all of us, including myself, and I'm just a layman, of course. I'm not in the industry. But this affects all of us as scientists who are at the top level. We're trying to get to the top. I am. If you're not, if you're just here to be entertained, well, that's why YouTube exists. But hopefully your form of entertainment coincides with the goals of science itself, which I intend to represent to you. And David Bohm is the right way to begin because he got an answer. Nobody else did. Dirac certainly did not. He admitted it. He died frustrated. Einstein did not get an answer. Bohr claimed that he had the answer, but it's the most interesting answer, for which basically he was awarded posthumously a Nobel Prize, you could say, in 2022, in October of that year. The prize in physics, you should study that. I have several videos on it. Highly controversial, because it was the first time that the Stockholm Committee had ever awarded a Nobel Prize in physics for justifying a philosophical point of view. But it was done with an excruciatingly difficult to perform experiment in order to prove that something is happening at the quantum level that defies the speed of light. Of course, this rather troubled Einstein, who essentially said, well, there has to be an explanation for why these things are happening. What things? You know it is entanglement, which is an interesting term. But what it is non-local position. It's position that can't be fixed in time. But it's worse than that. And this is what makes it so difficult to talk about. But I will tell you essentially what the problem is as I see it geometrically. That's how I approach this problem, is geometrically. It does have to have mathematics attached, but that is the correct hierarchy. And in this case, we're forced back to geometry, as our scientists should have known. But nobody's woken up to the fact that somebody dropped the ball in geometry. It was pointed out, I've heard this said more than once, by people who deal with this, people who are in the industry. It was pointed out that there is no geometry in quantum mechanics. There's no geometry at all. Which is interesting because general relativity does have a geometry. It is a spatial computation that does work for space flight, so there is something to general relativity. It certainly has proved itself useful. But it does have a geometry. It would have to, or it couldn't describe space. It's really a description of gravitationally influenced space in order to account for time lag of light travel, because light, it just turns out, takes time to travel. And since it does, your target for a light transmission signal will have moved by the time you fire the light ray, release the light signal toward its destination. The destination is moving while the light is trying to get there, so that's relativism. It's time lag. For changing position, there is time involved. Well, not in the quantum paradox, there's not. There is a defiance of something. It could be a defiance of time itself. But the nature of entanglement, which I much prefer to call coordination, it's the coordination of what would amount to a single state coordination, but it's a shared single state. and that's called coordination, which is given the baffling term entanglement, because an entanglement is like a net. But a coordination is something mathematical and geometric and logical. It's relational. Well, that's the right way to say it. Why don't they say it that way? Because they don't know what they're looking at. So they give it a superstitious name, just like the Big Bang or natural selection. They give it a superstitious name because they think that they are describing it best by these terms. Big Bang? You know, natural selection? The universe is expanding? They just say the strangest things. Well, they're admitting that they're baffled. But you see, in science, we get really frustrated with that. We're looking for the answer. Well, the answer to what? The answer to what happens when you discover that coordination defies relativity. That has been proved. That's what the Nobel Prize was given for, although it was turned into something strange. It was the burial of Einstein's memory in favor of Bohr. So Stockholm announced that Bohr won the debate. That's not really what the prize was given for, but that's what everybody ended up saying. Because there's this philosophical split. And the mechanists won, the atheists won. And it goes that deep. It's just the celebration of the atheists. They're just so happy to get rid of Einstein. Because whatever Einstein said about God, I don't think anyone doubts. He said it both ways, his belief in God. Well, just for comparison, this man Sheldrake over here, who is going to be talking about David Bohm, does he believe in God? I believe this is an extremely important question, although it's a bit personal, so it's dicey. But I believe every scientist today should declare when to say this is this is a very dicey issue, a man's religion. Well, these men know no shame. So what about Sheldrake? Well, what about David Bohm? David Bohm was an agnostic. I respect that because that's a scientific answer. It means whatever I think about God doesn't matter here. You don't need to know what I think about God. That's an agnostic. You don't need to know. Whatever I think about God is meaningless here. That's an agnostic. I respect that. My father was an agnostic. I don't see how you can challenge that. What you're saying is really the default correct answer from a scientist. I don't give a fuck. Why are you asking me that? Well, actually, I believe that needs to be asked now. The reason is because, well, let's just take a look at Sheldrake here for a moment. All right, I believe you can't see me, but you can see there's a question. Does Rupert Sheldrake believe in God? Sheldrake has said, I went through the standard scientific atheist phase when I was about 14. I bought into that package deal of science equals atheism. And then he says he refused to get confirmed at the high Anglican boarding school. So I guess that's his admission that he is indeed an atheist, but what an interesting way to say it. So there was our little introduction to Rupert Sheldrake, who is apparently a parapsychologist who has an interesting idea of resonance. It's a conscious resonance. So, he's very well spoken. This is really my first contact with Rupert Sheldrake, who's quite famous. Vernon apparently is a high-level physicist. Rupert is not, but he's a very good presenter. I really like his approach. I hope you like it too. Let's turn this on so you can hear this. What is being discussed here is in the caption. They're going to talk about David Bohm. And I have never heard a better introduction to David Bohm, and I've been studying David Bohm for quite a while. I think you'll see why. We're going to get at the quantum paradox, and I'm using this as a vehicle so I'll be able to tell you, for the first time, just what it is. That is the goal, is to define it. It's never been defined. That's why everyone's losing their mind. This is the most serious problem that's ever faced physics. And I claim that David Bohm got the right answer, but he could not translate it back. What you're going to hear is he did get it right, and it does match the mathematics, and certainly David Bohm would know. Einstein also approved this, and he's not the only one who approved it, but David Bohm had a most interesting life. So I'm going to turn this on, and Rupert will explain why this latest documentary on Bohm is actually a little bit dated, but it's a documentary about David Bohm's life called Infinite Potential, which you will watch. Or I don't even know why you're listening to me if you're not going to do what I say. I don't like to give homework, but in this case, I'll make an exception. You need to know something about David Bohm, and I'm here to give you that introduction, which I think is superb. I hope you agree.
Mark, what I want to talk about today is this new film that's just come out on the life and ideas of David Bohm called Infinite Potential. Not everyone's probably aware of Bohm because he's not one of the most famous scientists like Einstein, but he was a very important and influential quantum physicist, and I think went way beyond most other scientists in his deep thinking about the nature of reality, consciousness, and indeed science. And I think the film brings that out really clearly. It's a surprisingly good documentary film. I'd expected it to be just talking heads, and of course there are some talking heads, but it's very well made. And I think that it also brings out the historical context where Bohm comes up with an interpretation of quantum theory as a young man. He was a brilliant mathematician at Princeton, the protege of Einstein, his spiritual successor in many people's view. But then he goes against the predominant view among quantum physicists, particularly Robert Oppenheimer. And then I think it's very telling the way that when he publishes his paper on the quantum potential, showing that instead of being just random events, quantum phenomena may have a guiding field underlying them, an invisible guiding principles which give them shape.
An invisible underlying field.
Something that wasn't the way other quantum physicists thought, but which works perfectly well with the mathematics. And when Oppenheimer convened a meeting to say, we've got to try and refute Bohm, and when they found they couldn't refute him, then he said, okay, then we just ignore him.
Perfectly matches the mathematics.
Cast out from the scientific establishment.
Ostracized.
He was driven out of the United States because he'd had some tenuous link at some stage with some communist party people, forced into exile in Brazil, later in England.
Not Oppenheimer, Bohm.
And so his life was completely transformed by this persecution by the science establishment. But he then, in a way, it was a blessing because he then went on this quest to find a deeper meaning and understanding, particularly of consciousness, which quantum theory raises as a question. And then his long friendship with Krishnamurti and his many dialogues with Krishnamurti. All this, the film brings out, I think, really well.
Yes, it does.
And raises a number of deep questions about the nature of science, the scientific process, the relations between science and consciousness, and the deeper issues in quantum theory. I thought to achieve all those things in a single film was quite remarkable.
Yeah, no, I agree about the quality of the film. I was really pleasantly surprised by that and could just relax and enjoy it. It's got the talking heads. I mean, big talking heads, people like Roger Penrose. It's got a lot of good use of archival material. It tells this tragic story, actually, of his ostracization from the US. But also has wonderful graphics and really tries to communicate his ideas, his way of understanding quantum theory, which is quite hard to understand. I mean, I did a physics degree, and I remember vaguely hearing about the Bohm formalism of quantum theory and being told that the maths was, way beyond most postgrads' maths capability as well. So it has this sort of slightly daunting feel, I think. But actually, can be shown the basic ideas of it quite well. And they also show how it's being tested during Bohm's own time when he came to Birkbeck here in London. But it's ongoing now, actually, the work's ongoing. There are people trying to both get the funding, but also perform the experiments that can show the validity of his formalism of the quantum theory. I mean, one thing that I really liked about it as well that I felt came across very strongly is how the different key figures working on quantum mechanics drew on their perception of reality, whether that be psychological or more overtly spiritual, in order to shape the way they developed the mathematics of the quantum theory. So Bohm, as you say, through his dialogues with Krishnamurti particularly, had this powerful sense of the links between observer and observed, and also the idea of something implicate, therefore unfolding into the explicate and then folding back into it. That was a perception that comes from spiritual practice that can then be shown to stand up as a way of accounting for quantum phenomena. But conversely, someone like Niels Bohr, the don't ask, just calculate approach, that represents a take on reality. It's not, as it were, implicit in the quantum theory. It's an approach you take to the evidence and the mathematics to try and make an account that stands up. And then I guess figures like Heisenberg, who represent a different take again, famous for the sense of uncertainty at the root of all things, and that, of course, Einstein so much disliked. That came, again, from a different tradition, a different kind of philosophical account of reality. And so the film showed for me very much how thinking that quantum physics somehow proves something about reality gets it all wrong. That this is already a kind of multi-layered approach to reality, and the physicists take all they've got into their investigations. And there's a much more complex interweaving of all these things. And, as someone like Krishnamurti clearly had, if you have a perception of reality informed by spiritual practice, you should have the confidence of your own perceptions, want to investigate, want to test, want to make links for sure, but not, as it were, reach for a bit of otherwise quite poorly understood quantum mechanics in order to try and make it prop up. And so...
All right, I hope you appreciate what was said there about this approach to quantum mechanics. David Bohm has implicated a different point of view which is typical of a serious quantum mechanist. Bohr was cited as a good example. Einstein, obviously of a different frame of mind, in approaching the whole meaning of what we're looking for. The technical difficulty is the violation of lightspeed. I think that's probably the best apprehension of the problem, such that it can be apprehended, that there is a violation of lightspeed. But the way that lightspeed is violated has a deep impression on the human mind, and it induced more than one technical scientist, mathematically oriented logical scientist, to consider the typical methods of science to be inadequate for this situation, demanding a new level of regard. It's really a frame of mind. And there's a feedback system here, which is pointed out, which I think is the most interesting aspect for someone like you or me, who are just fascinated with interesting problems. We would at least like to understand how this magic trick is done. Is there anybody who can take us behind the scenes and show us just what is baffling these great minds, such that it induces them to metaphysical extension? The feedback is that, and this is true in Bohm's case, you have to be brutally honest with these situations. Bohm found his own technical acumen with mathematics. He's on the level of Einstein and Bohr and all the others. Bohm is not one whit behind them. Einstein really regarded Bohm very highly. He had some technical difficulties with, well, Einstein had technical difficulties with everybody, because Einstein said what I say, which is essentially his approach is God does not play dice with the universe. I just find that to be a remarkable statement from a man of Einstein's stature. God does not play. Now, he was talking with Bohr, and Bohr had a way of just dragging people. Bohr was apparently indefatigable, and he was a fierce and somewhat raspy debater, but he could outlast anybody he debated with. He made one man sick. I think it was Heisenberg, but he wore out Einstein many times. And Bohr would just talk forever, because what was Bohr's point of view that made Einstein, want to debate with him? Bohr just gave up. He said he was prophetic, because he certainly was justified just 3 years ago. Essentially, Bohr got that Nobel Prize long after he was dead, which, by the way, it's not given posthumously, as Henrietta Leavitt found out, although not really, since she was dead, so she didn't find out. She found out maybe from wherever she is. She's apprised of that by now. That she should have been the first woman to win the first ever Nobel Prize in astronomy. But she didn't, because she died of cancer, and Stockholm didn't know in time before nominating her. So where Bohm comes into the picture for us in getting at the heart of the quantum paradox is that it does involve superposition, which involves people at deep level. The feedback that I keep trying to come back to explain is that by achieving a metaphysical, actually a holistic solution, somewhat outside of the purview of science, but Bohm tried to shoehorn it in, which they all do. Bohr is just kind of like the magnificent exception. He felt that he didn't have to do anything, because his point of view was, you'll never understand it. Don't be ridiculous. You'll never understand it. That's what Bohr said. Well, Einstein, of course, disagreed, because his whole premise, same as mine, is that you're crazy, Bohr. It's really that's you're crazy. Well, it doesn't sound like science. It's because it's two different approaches, and you need both. It turns out that Bohm, his whole life proves, if you're willing to credit Bohm, which I am, he saw through the problem and achieved an answer. And he's the only man who's ever achieved an answer at all. So it was going the wrong way for the government. The government didn't want men like Bohm getting people interested in the truth. What if there is a holism? Does that mean that Bohr is right and we'll never understand it? Well, I'm here to tell you, no, that is not what that implies. What it implies is self-indicting for them, for really linear mathematicians, who that's all they use is linear mathematics, right? Well, my solution is you're using the wrong mathematics. So I'm in the same situation as Bohm. You can't say that. You cannot say anything non-Euclidean. Science is Euclidean. Einstein used Euclidean geometry. They all did. They all do to this day. There's no other form of geometry. Well, there is in the universe. The universe doesn't even use linear geometry. It uses spherical geometry. You can look it up in Wikipedia. I keep checking. Just look around through the universities. Anybody know anything about spherical geometry? The flat out, straight up answer is no. There's no such thing as spherical geometry. Well, I, as a geometrician, or you can say geometer, that actually is a word, we use mathematics. Mathematics is derived from geometry. That's why all of our science is Euclidean. Euclid wasn't John Horton Conway. He wasn't von Neumann doing number theory. He certainly wasn't Cantor. Euclid was a primitive Greek who drew lines in the sand. Well, he sure did a lot with those lines, didn't he? Yeah, but nobody's ever gone back to check. What the fuck did Euclid do to us? He started out with a sentence that defines mathematics and defines all the problems with mathematics is in the first sentence of Elements. And if you read the first two sentences, you've gone from the point to the line. Where's the problem? The point. He defined the line as based on the point. Well, what's the definition of that point? Every problem in physics today comes from that point. And the reason is, it doesn't exist. He defined it purely as position. Well, why then didn't he define the medium of the position? It wasn't until René Descartes that somebody decided to draw the grid that everyone had been using. And now everyone knows it's a grid, but it always had been. Well, does the grid match the universe? No. No, it doesn't at all. And that's why you have quantum cohomology. That's why you actually have quantum spookiness, is because of being an ant on a surface where you don't realize that you're on a surface. Euclidean geometry does not even know what a surface is. Do you know why? The reason is, discovered in the 20th century at all levels, it's because everything in the universe is spherical. Well, that's not a line. Well, it's not a straight line. It's a curve. Well, you can't see it. Euclidean geometry does not know anything about what is a curve. Do you know why? It's because it uses a different mathematical level. It's a different form of mathematics. It's the mathematics that you and I were taught. It's a subset of that mathematics. And it's a subset of the linear number system. It's a very specific number system. But it's completely nonlinear. And it causes a split in the mind. Because instead of having a 1 number, you have a 2 number. We use it in complex analysis. That's a 2-component number. A complex number is a 2-component number. It has 2 linear coefficients. The basis of the real component is linear Euclidean. The basis of the imaginary component, which is the y-axis on the plane, the Cartesian grid, it is not linear, although it's linearizable using conjugate algebra. So the complex number system introduces a new level of algebra. And the miracle that makes it the exclusively used number system now, you only use complex numbers. If you're in graduate level work, you only use complex numbers. You leave behind all other numbers. In quantum mechanics and in astrophysics, you use complex numbers. Only complex numbers. Do you know why? Essentially, it's because it's a two-component number instead of a one-component number. So that's the basis of the mathematical split, is that you need a different mathematics to compute curvature. That's why the complex number system was invented. Or you could say discovered. It is a trick, but it works. That's why it's exclusively used. Do you know why it's so miraculous? Why are the complex numbers used? It's because you can mathematize curvature more conveniently, but you don't get around the problem. Complex numbers are inadequate for the job. I discovered the actual solution that replaces the complex number system. So that's not going to be acceptable. That is not acceptable, and it will not be accepted. For the same reason that David Bohm was ostracized, sidelined, and hounded out of the country. That was an extreme case. But it happens all the time. Scientists are ruthless in their natural selection system, which of course is unnatural. A guy like David Bohm is not allowed because he introduced a non-linear solution, a non-Euclidean approach. That's already been disproved according to the reigning model, which is Bohr's. That Einstein is dead now, and the atheists are on top. It just so happens that they're all atheists. What a coincidence that every last one of these jackasses is atheist. They say so, which is an anti-scientific posture. So this is a war to the death between the sons of light and the sons of darkness. And you don't need to worry about who's going to win. It's over. It's all over. Nobody can say precisely when it ended. That is all hope for rational logic. But, I mean, I'm here. Bohm did his best. He was hamstrung. They all are. I'm the only free bull. I'm the only one that shook off the shackles. Bohm could not. But he may have gotten something better. And don't ever discount what was said, even by Sheldrake the atheist. He admits the power of his enemy. He himself is trying to do something similar, I think, to Bohm, but each in their own way from their own context. Was Bohm an atheist? No. And you know who validated that fact? The Dalai Lama wrote a preface to Lee Nichols' summary of David Bohm's work. I strongly recommend that book, if for no other reason than to read the preface written by the Dalai Lama, who said that David Bohm was his science guru. And that's our tribute to David Bohm. I hope that induces you to see that documentary. I have links posted to where you can find it for free. I just joined the David Bohm Society. They call themselves a society, but it's really an institute. And they're at the cutting edge of science right now. I'm not sure where they're going. I would imagine they have their own ideas. But I'm here to just do what Einstein wanted to do, what Dirac wanted to do, and solve this motherfucker. So I have the solution. but it does require you to abandon your industrial point of view to reality. Yes, there is a God, and yes, there is truth, and yes, we're going to get the answers, and no, you're not going to stop that. You go ahead and build your bomb, but you're not going to stop science. David Bohm got as far as any man ever did, and I am David Bohm's successor, just as I'm Einstein's successor and Dirac's successor, to get all the answers that not even Feynman could even begin to comprehend, because he didn't know geometry. That is called being an honest scientist. So that's my approach. And I couldn't care less about anyone else's approach. Unless you're after the truth and you prove it. He proved it. He was branded a communist by his own community. The greatest scientist of the 20th century in his class. So is Halton Arp. So is Fritz Zwicky. These are men I admire. It's a one-to-one correspondence between the men that I admire because they're after the truth and they do it right, to instruct the youth like me to get going and know that we're going to win, we're going to get the answers, we're going to be successful. Those men that I admire are exactly the ones that the other scientists hate and seek to sideline and seek to drum out of existence. And now they're all atheists. Isn't that a coincidence? Stay tuned, keep looking up. We'll be back with more. Thank you.